Okay, so when I say what kind of power having more compute buys you, I'm just want to give a very concrete example. So this is a sort of a small, medium-sized field project, and what we're comparing here is two initial models, two initial guesses. Scenario A, scenario B. Now they look almost exactly the same, right? When you look at it, you have to really squint. The real difference is that the water horizon is defined a little bit differently in this one, and the water sort of density contrast ratio to Earth, that sort of function is defined a little bit differently in this one. Okay. Now this kind of thing is very hard to calibrate for when you're just sort of running it blind. And if we don't have enough compute, you basically say, oh, I only have enough time to run one or two different scenarios, so I'm just going to guess what these things are. But they may have very large effects on your final result. So if you look at the results that we got, mid-inversion after 10 iterations, what we're measuring here is sort of the average trace correlation, right? So it's -1 to 1, and so this is in percentages, right? So 100% is fully correlated. Your predicted data fully matches your field data. So if we start off with, this is what we want to start off with. If we just use all default settings in our software. And you can see initially the trace fit is 35%, and then in the end, after 10 iterations, we got to 60%. But if we just tweak the water bottom just slightly, just a little bit, immediately, without doing anything, our trace fit was 56%. And not only that, when we iterate, we're able to get to a better trace fit than this case. So not only do you start closer to the true solution, you also end up with a better solution.